Welcome. In this video, I will discuss static two-dimensional arrays in C++. So, what are static two-dimensional arrays? Well, the simplest way to think of these two-dimensional arrays are lists of lists. And what does that mean? Well, we have a one-dimensional array that is of size m, and this one-dimensional array of size m is going to keep track of the address of m one-dimensional arrays of size n. So we are going to have two dimensions to this array. It is going to be an m by n array. So like a 1D array only has one dimension. This one has two. And the m dimension is going to keep track of the addresses of a bunch of arrays that are of size n, and you need to have m amount of those arrays of size n. And the compiler will do all of this for you. And the elements of all of these arrays are going to be of the same data type, and the arrays that we are going to be covering are static, just like with one-dimensional arrays at this point. The arrays are static, meaning they have a fixed size. So the array's memory is going to be allocated at compile time. So the compiler needs to know the size of the memory that it needs to allocate for the array. So you need to make the array one size and keep it that size for the entirety of your program. Now, let's talk about how we can declare these static two-dimensional arrays. So just like one-dimensional arrays, you need to provide the compiler with three things. And that is going to be the data type of the elements in the array, the name of the array, which is just the identifier of the array, and the m and n sizes of the array. And the syntax to do this looks just like this. It is the same as when we are making a one-dimensional array where we give a data type, a identifier, and then a dimension. But instead of only having one dimension, we have two dimensions. So instead of only putting one number here, like 5, and having a list of 5 elements, if we put a number 5 here, and then we put a number 2 here, we will have a two-dimensional array with 5 rows and 2 columns, because this m is going to be the number of rows in the array, and this n is going to be the number of columns in the array. And just one thing to note, these orderings can be in either row or column major for m and n, but I will always use row major. So technically, yes, you could use this as columns and this as rows, and that would be column major, but I do not like that. I like row major. So all that means is that the first number will be the rows and the second number will be the columns. Now, let's learn how to access elements of a static two-dimensional array. Just like one-dimensional arrays, all of this is the same as one-dimensional arrays. You may want to access an element of an array to output the value, to use the value, or to update the value of an element. But what is different from one-dimensional arrays is that when you want to do this, instead of only using one bracket, you are going to use 2 brackets. And the syntax to do that looks just like this. We are going to use the identifier of the array, and then the row number we want to access some data from, and the column number we want to access some data from. And this row and this column needs to be non-negative, and it needs to be within range of the dimensions of the array -1. So if this is a 10 by 5 array, this row number can be either 0 through 9, or this column number can be 0 through 5. And now let's look at an example of declaring and accessing the elements of a two-dimensional array. So here we have a line of code where we make a two-dimensional array which has 2 rows and 10 columns. We see when we run this line of code, we get something in memory that looks like this. It is a giant block that has 10 spaces for our first row and 10 spaces for our second row, because we have 2 columns, 2 rows, 2 rows, and 10 columns, 1, 2, all the way up to 10 columns. And note the index of those rows and columns start at 1, so they go to the size of the either n or m minus 1. So when we do something like this, where we say the array at row 0 and column 0, we want to place the element 20. When we come down here, we see that the element 20 gets placed at 0, 0. When we say something like, at the first row in the 5th column, let me place a 7. So we go to the first row and the 5th column and place a 7. When we say in the 0th row, in the 9th column, I want to place 99, we go to the 0th row, place a 99 in the 9th column, which is the last column, which again is the n size minus 1. And then here we have at the array in row 1 at column 7, we want to give 1023. So you see in row 1 at column 7, we get 1023. But if we did something like this, where we are going out of range because this is greater than the n value minus 1, then we are hopefully going to get a seg fault. That way we know we went to an invalid place in memory, but probably not in this case because we didn't go far enough deep in memory. So that is just an invalid place in memory, and hopefully we'll just get that abort trap that we have seen before. But as you see, we don't get that 27 placed anywhere in our array because that is an invalid index of our array. So let's take a look at static two-dimensional arrays from a program. Here we have an m and an n, which are constants. They must be constants, again, because the compiler must know what the size of those arrays are going to be. And if they are not constants, then these values can vary, so the compiler would not be able to know, so you'll get an error if you try and do this without being a constant. So we take those constants and we use them to create an array, which is a two-dimensional array, which is 2 rows by 10 columns. We then come down here and initialize that array using a double for loop. Whenever we want to initialize a two-dimensional array, we must use a double for loop. This is because we must iterate over the rows and the columns. Right here, we are iterating over the rows. Right here, we are iterating over the columns. So we go through the rows and then through the columns. So the first time we go through this iteration of this outer for loop, this inner for loop will fill the first row with the j elements, or the number that j is. So the first row will get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it will loop around, and since this is 2, it will iterate one more time because that I will increment to 1. This will again fill the second row up with the numbers 0 through 9, and then it will come back around, and since we only have 2 rows, it will break out of here, and then we will come down here and print the elements. And again, since we are working with two-dimensional arrays, we need a double for loop. So in this double for loop, we are going to iterate again over the rows in the outer for loop and the columns in the inner for loop, and output the elements with a space in between each element. So it will output the first row during the first iteration of this loop, and then a new line, so that first row is on its own line. It will come back around, increment this I to 1, come back into here, output the second row, which is 0 through 9, with a space in between each number, output a new line, so that row is on its own line, and then come back, that I will increment to 3, or to 2. 2 is not less than 2, so it will break out and exit our program. So all this will do effectively is initialize our array and then print that array out to the screen. So let's open up a terminal window and see that in action. We can compile this program with G++ and the name of the program, and then we can run it with ./a.out, and you see we get 0 through 9 output to the screen twice, again, because we have a 2 by 10 array, so that is 2 rows, 1, 2 rows, and each row should have 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then here's our second row again with 10 elements as well, which again, they are these numbers from this initialization right here, where we are going through the first row and then through the second row. Whoopsies, that went down too far. In this loop right here, the first row, and then we go through the second row, which will fill those 2 rows with the numbers that J is going from. Since N is 10, it will go from 0 to 9. So we get 0 through 9 in each row. And then we come down here and just print them and exit the program. And that is all that I have for you for this video. Thank you so much for watching. We'll see you in the next video.